Hello, this is me. I'm M.Romeo from NCE Analytics, and this is the first part of our inside travel um, about neuralized complex systems. I want to remark the fact that a complex system in the general view of a system in nature is something which is related usually with non-linearity, but also in the case you have a linearity from an overall point of view. Usually you have so much parts in a relationship among them that you cannot understand really the some model in which you can focus the behavior of the system, of the whole system, so that if you have a complex system which is made of several parts, you have to consider that usually you have to write some model by considering 2 parts by 2 parts every time. Anytime you write a model, a partial model, from a couple of parts in the entire system, then you repeat this operation and then you go on up to the end of the system. Then you have a certain number of equations. Usually you have a partial differential equation related to the continuous nature of the things around you if you don't consider some aspect of the quantum mechanics, and then you have a classical behavior of your system. Then you have to put inside your equations the parameters you need to tune your model in function of the initial condition and the boundary condition you have to reproduce some behavior which you observe in nature or in your laboratory. Then maybe you can observe in parallel some aspect of the so-called neuralized systems. When you have a neuralized system in comparison with the brain tissue of our inside system, in our head, maybe you can observe then you have a certain kind of relation among the parts that you can recognize inside your system. Then maybe you can write your equations, your system of equations, in some manner which is very different with respect to the mass of equations you can have to describe some behavior respect to some other. Then maybe a neuralized complex system is a certain system from a point of view, from the point of view of a physicist, in which you can recognize a precise behavior of the underlying equations you have when you once you have put the correct parameters inside the elemental model that you want to use to describe the nature of your system. So in way that you have some kind of system in which relation between parts, relation between different parts, can be described by a neural model from the point of view of the mathematics that you have in the usual neural systems. And then you can recognize a neuralized structure in economics, financial stuff, in society, in biological systems, in the human brain, of course, then in some kind of systems of many particles, billions and billions of particles at classical level. And then you can repeat these considerations also from the quantum point of view. Then you can write in a different way, and this means that you can observe in a different way a system when you consider that you can repeat the same operation usually you make to simulate a certain neural network to obtain some result for your system when you want to obtain some precise result in order to accomplish some target. I don't know. So maybe you can recognize in your equations, in your system of equations, the correct behavior of your system better than the system in which you consider as usual your equations with simple parameters. But if you have a neural system, if you have a complex system in which you consider a neural structure for your equations, and then you put your parameters inside this system, and then you consider this system, which is complex from your point of view, like a neural system, and you treat this system like a neural system of equations, and I will explain subsequently what it means, then you can obtain your results in a different way, more confident with the practical point of view of the question. Then you can obtain results you want in a way that is more affordable for your target, for your needs. I mean, this is usually the point of view of a physicist, which work with equations. Then you have a way to manage a complex system which can be neuralized in order to accomplish a certain target from your point of view, just by managing equations, putting them in a form that you can consider a neuralized system. So that I think this is enough for the first time in order to start with our discussion about neuralized complex system, and I think that it can be more clear if we do some step back to understand something more in deep about complex system before to go on with neuralized system. So I wish you a nice evening, a lovely evening, and bye bye. See you next time.